In this video, we're going to solve a complex trigonometric equation that involves both inverse trig functions and trig functions. So first of all, I need to start somewhere. So I'm going to choose to let the inverse sine of x equal theta, which means that the sine of theta equals x. Now we're going to hold on to that. And also I notice here on the left side that this side involves both sine and cosine. So I want to use a trigonometric identity that involves both sine and cosine. And I think one that will work here would be the Pythagorean identity. Since ultimately on this side of the equation we have cosine of something, like some angle, I want to solve this trigonometric identity for cosine theta. So we would have to subtract sine squared theta from both sides. We would have to take the square root of both sides to get cosine of theta equals plus or minus the square root of 1 minus sine squared theta. But let's keep in mind that sine of theta equals x, so this piece of the expression can be rewritten as x squared. So we make that substitution there. And also, because up here, inverse sine of x equals theta, then it follows that theta has to be between negative pi over 2 and pi over 2. And that's just what we know about the inverse sine function. Now, if I apply the cosine on that interval, the cosine would have to be positive or 0. In other words, I will not consider the negative square root. So I'm only going to keep the positive. So we end up with the left side of that equation up here at the top is equal to the square root of 1 minus x squared. So now I'm going to move on to the right side of this equation, and specifically I'm going to focus on the inverse cosine of 24 over 25. I will also call that theta, but since this is a different theta here, I'm just going to put theta sub 2. From this equation, I could rewrite it as the cosine of theta sub 2 is 24 over 25, where theta sub 2 must be between 0 and pi, because that's what we know about the inverse cosine function. This value is positive, so that means that it must be in the first quadrant. So just to make a quick little sketch here, here's my theta sub 2 right here. I know that the cosine of theta is adjacent over hypotenuse in reference to this particular angle here, this acute angle. So that means this side must be 24, the hypotenuse is 25, and now I can use the Pythagorean theorem to solve for the missing side there. And I find that side to be 7. So with this information, now I can get the tangent of that angle. Tangent is opposite over adjacent, so that would be 7 over 24. So now I can re-express both the left and the right side. This was the left side of the equation, and this is the right side of the equation. I'm going to set those two things equal to each other. So I'll first start by squaring both sides. Then I want to subtract 1 from both sides, divide by the negative 1 that's understood to be here, and then take the square root of both sides to get x by itself. Now, I know that the square root of 576 is 24 because I just had to square 24 to get there. But next, I'll just need to check, can I simplify this numerator a little further? But it doesn't look like I can. So in the end, this is what we end up with. X is equal to these two possible values.